That's this idea of this learning paradox. The group that does really well in practice tends to do poorly on the test, and then the group that doesn't do well in practice ends up doing quite well on the test. So it's paradoxical because that's not what you would expect. You generally expect that if you perform well during practice, that will transfer to competition or testing situations. And so from a practical application point of view, that's really important to consider because we might need to sacrifice some practice performance to really enhance long-term learning. And I think if you asked any practitioner out there, is it better to have people perform better during practice or during competition? I think most coaches would say, I'll take the competition performance.
Welcome to this episode of Coach Noah Talks, where I have the pleasure of speaking with Jared Porter, Director of the Motor Behavior Lab at the University of Tennessee. His research investigates how humans learn and relearn motor skills and how we generate skillful movements. Our topic today is motor learning. I'm excited to have him on the show to share his insights and knowledge. Good morning, Dr. Porter. Thank you for taking the time to speak with me today.
Yeah, good morning. I appreciate the invitation. Happy to be here.
Let's start with your academic and your professional background and what you've been doing over these past years.
Going back to the beginning and where this all started for me, my original professional career goal was to be a football coach. I wanted to coach at the college or professional level and had an opportunity to start doing that early in my career. And a couple of big revelations set in pretty quick for me. One was that when you coach at that level, you actually don't spend a lot of time coaching. You spend the bulk of your day doing all the other stuff, prepping for a narrow coaching opportunity during practice or preparing for competitions. But I think more importantly, when I was an undergraduate student, I took some coursework in motor learning, skill acquisition, and it really blew my mind. It felt like I was being exposed to the curtain being pulled back, that there was all these kind of secrets being revealed to me. And so when I started coaching as a job, I kept finding myself at the library reading research related to skill acquisition, practice schedule design, trying to learn better techniques and methods just to be a better coach. I kept finding myself talking to researchers that were studying some of these topics. And after a while, I just came to a revelation of, man, I should be doing this. I should be doing the research. I should be studying these things. And so that led me to graduate school. So I went to LSU or Louisiana State University, ended up doing a PhD with a guy named Richard McGill, a juggernaut in the field of skill acquisition and motor learning, and worked in his lab and had a great experience. Then from there, I had some opportunities to work with high-level athletes across a variety of sports and medical populations, and started my academic career at Southern Illinois University as a professor, was there for a number of years, and then an opportunity came up here at the University of Tennessee in Knoxville, and so made the transition to this institution. Been here for 5 or so years now, and I'm the director of the Motor Behavior Lab here on campus, and I'm so fortunate to be surrounded by incredibly bright students that energize me every day, and wonderful colleagues and collaborators here at the institution, and just also at other places around the world. That's got me to where I am today, in short.
And so I came across your work specifically related to something called contextual interference. Before we go into some of the research that you've conducted, can you explain what is contextual interference?
Contextual interference as a concept is this psychological phenomena that occurs whenever we are practicing 2 or more skills within a practice session. If we want to think about a golfing specific example. So if you go to the driving range or you go play around a golf, you're probably not going to do the same thing, be it use one club, hit the exact same shot every time during practice. You're probably going to change your club periodically or hit the ball to a different target. And so as you start to change the task or the characteristics of the environment, those variations of skills start to interact with one another. And that interaction creates contextual interference. Again, it's this psychological learning phenomena that emerges whenever you're practicing 2 or more things within a practice session. So many times within a practice session, you're going to practice a whole host of variations of skills and different tactics and strategies. And so based upon how those skill variations are ordered in a practice session, it can create more or less contextual interference. So if you go to that practice session and maybe you grab your 9-iron and you hit a bunch of the same shots in a row with a 9-iron, that creates low contextual interference because you're going to finish all of the shots with that one 9-iron before you switch to a different club. And then let's say you decide, okay, now I'm going to work on my short game. I'm going to putt a bunch of shots from the same location to the hole. And so then you do a bunch of those, and then you stop and you move on to, okay, now I'm going to work on driving. So you do what are called blocks of trials. So you do all of the 9 iron shots in a row, then you move on to do the same putts in a row, and then you move on to maybe drive a bunch in a row. Since you're doing those blocks of same task trials, it creates low contextual interference because those 3 variations of the golf shot are not really interacting with each other at a very high level. In contrast, what you could do is more of a random arrangement. So you could take those same 3 shots, or your 9 iron, your putt, your drive, and then maybe every time you take a swing, you change something, and you're doing a different shot every time. Now, all of a sudden, those 3 variations of the skills are strongly interacting with each other, which creates more contextual interference and the psychology of all this. And so as you begin to think about how you order the arrangement of practice trials, again, it's like a dial. You can turn up the contextual interference by making things more random, or you can turn it down by making things more blocked or repetitive. And that's something really important to consider, because what all the data tells us, I mean, there's decades of work out there on this, is that you very often will see this learning paradox. And that is, if you practice with block scheduling or low contextual interference, during practice, you end up doing quite well. However, when you go take a test or when you go play around the golf, all of a sudden you perform quite poorly. The reverse is true as well. And so that means if you practice with high contextual interference or random scheduling, usually during practice you don't do very well, but you reap the benefits when you go take a test or you go play around the golf. And so that's this idea of this learning paradox. The group that does really well in practice tends to do poorly on the test, and then the group that doesn't do well in practice ends up doing quite well on the test. So it's paradoxical because that's not what you would expect. You generally expect that if you perform well during practice, that will transfer to competition or testing situations. And with contextual interference, we generally see the reverse of that. And so from a practical application point of view, that's really important to consider, because you've got to have an awareness that we might need to sacrifice some practice performance to really enhance long-term learning. And so we do well on the test or in a competition or a golf tournament. And then just because somebody is performing well during practice isn't always a great predictor that they're going to perform well on a later test or competition. So that is a very brief synopsis of kind of what contextual interference is and a brief review of the general research findings that we see. So a lot of my early research that I did was on the topic of contextual interference, and I still have a line of that research going today.
I think the challenge is, it makes sense when you listen to that, but the challenge is that from a coaching perspective, it's hard to see your student or your player struggle. It's much easier to give them that safety of, look, you hit 5 in a row and it got better. Yeah. And then I look like a good coach because I helped you get an immediate result.
Yeah, and that's, I think, for me, both as a researcher and a practitioner, is just having that conversation up front. So if I'm working with coaches, I just fully disclose, hey, we're going to do some stuff, or I'm going to suggest we do some things in practice that may actually depress motor performance initially, but understand it's going to pay dividends later. If I'm working with an athlete or a learner, same conversation. Let's talk about this. So we're going to do some things where you might not be doing as well as you would like in practice, but you're going to get those dividends later. And so understand that and expect it. And so I think that's really important versus not having that conversation with a coach or a learner, and then people being frustrated and confused. And so I just disclose it. Just tell people like, hey, we're going to do some stuff that it probably goes against the normal way that you've practiced because of those initial feelings of success. A lot of people will default to practicing with low contextual interference because it honestly feels good. I'm having some at least perceived success. I like that. It's more motivating. Let's keep doing that. But people don't oftentimes know that's actually going to hurt them in the long run. So I've just found that if I just talk to people up front and explain some of the science, you get pretty quick buy-in. As a coach, we many times want to give people some of that early success to keep them engaged, to keep them motivated. Again, the science tells us on this, that's not going to promote long-term success. And I think if you asked any practitioner out there, what's more important? short-term or long-term success? Or in other words, is it better to have people perform better during practice or during competition? I think most coaches would say, I'll take the competition performance. Okay, then we're in. Well, let's do that. Let's focus on getting people better during competition.
And you've alluded to some of the research findings. Can we just dive a bit deeper into the one study titled The Effects of 3 Levels of Contextual Interference on Performance Outcomes and Movement Patterns in Golf Skills, just because it's specific to golf? Any additional insights that you can share based on that now that we have a better understanding of what contextual interference is and how more contextual interference generally leads to better retention and long-term performance?
Yeah, and coincidentally, a lot of my early research on this topic of contextual interference used golf skills. And again, full disclosure, it's not because I'm just inherently interested in golf, which I am, but these types of skills just lend themselves really well to investigate these research questions. So this particular study that you referenced a moment ago had these learners come in, and from what I remember, these were low-skilled golfers, not complete novices necessarily, but these were folks that were not intermediate or highly skilled at all, pretty low skilled. And so we had them come in and practice with either low amounts of contextual interference like block scheduling or intermediate amounts of contextual interference, which is usually called like a serial practice schedule. You do like task A, task B, task C, then you go back, do task A, task B, task C. So every trial is something different, but it is predictable. Then a high amount of contextual interference is totally random. So every trial is different and it's not predictable. So it's this unpredictable random pattern. So we were just curious and really trying to investigate 2 questions in that study. One was, how does changing that amount of contextual interference improve golf shot accuracy? The second thing is, how do those different amounts of practice schedules begin to impact golf swing kinematics? And so really important thing for me to point out for this study is we gave these participants no instructions about how to swing a golf club. We just essentially said, the ball is here, hit it to that target over there. And the target was located several meters away. Without giving them like any sort of instruction about how they should swing or their mechanics, it's just go from point A to point B, go. And we're going to change the order in which you're doing these shots. And what was interesting is that we found results when we looked at shot accuracy that were consistent with the larger body of work, which is that when you practice with a block schedule or low contextual interference during practice, that group of participants was more accurate compared to the groups that practiced with higher amounts of contextual interference. But then when we gave them a later retention and transfer test, we saw the reverse, that the blocked group, who is really more accurate in practice, ended up doing quite poorly on that later accuracy test. And then the groups that practiced with higher amounts of contextual interference, which were not as accurate during practice, ended up being much more accurate on the later test. But the thing that was really interesting in those findings was that we saw changes in swing kinematics. Without telling these people how to change their swing evolved into being something more efficient and effective. And the evolution was one in that, like during practice, the block group had a better swing kinematic, a more effective swing trajectory angle compared to the higher CI groups. But then when they took a later test, their swing fell apart, which then explains the less accurate shots. Whereas the higher CI groups during practice did not display great swing mechanics, but when they came back later and took that retention and transfer test, they displayed a more optimal swing pattern. And so that was really striking because, again, we never gave these people any instructions about how to swing the club, but they were learning swing mechanics without being taught swing mechanics. And we achieved that objective by simply rearranging the order in which they practiced their shots. Ended up resulting in better accuracy on a test and more effective swing mechanics. And so that was pretty eye-opening. I think that was the first study that ever really demonstrated some of these clear changes in kinematics when it comes to swinging a golf club without giving instruction about how to swing the golf club, and just looking at, we can just alter the contextual interference of the practice schedule and not only affect shot outcome accuracy, but also shot production within the swing kinematics.
A follow-up on one of the other papers titled An Examination of the Contextual Interference Effect and the Errorless Learning Model During Motor Learning. What is this errorless learning model, and what were the findings from that?
This starts to move into another area of research that deals with what's called implicit and explicit learning. And so this idea of having more of an errorless learning schedule, which as it implies is one in which you practice in a way that promotes more success versus an error-full practice environment, which usually means the task is more difficult, which then causes the learner to make more errors. And so this was an initial study just recently published that looked at how we can arrange some of these errorful and errorless practice arrangements to promote implicit motor learning through contextual interference paradigms. And this was the initial study into this idea or this area, and it didn't involve golf-related skills. But what it generally showed is that by creating more of an errorless learning environment through the promotion of contextual interference, you can facilitate motor learning, which again, I think is consistent with the larger body of work. But I think we need to do much more investigation on this because it's a relatively newer idea in terms of understanding how these errorful and errorless practice arrangements interact with the contextual interference effect. But a pretty novel finding, and I'm excited to continue looking at this in the future.
I want to clarify that I'm understanding correctly that using contextual interference, basically, we want to create errorless environment. Is that saying absolutely no mistakes at all, or it's just like a spectrum of less errors versus a lot of errors?
Yeah, it's a continuum or a spectrum. So it's not about promoting no error. That's where I think the labels that are used in the research, it's a bit of a misnomer. It's not quite accurate because like errorless does imply no error. It's really less error versus errorful, which is just more error. And I think it's maybe better to coin this in terms of like more or less difficulty. But if you have a less difficult practice environment, that's going to result in fewer errors. If you have a more difficult practice environment, it's going to produce more error. And so I'm not a huge fan of the phraseology of errorful and errorless because I think it's misleading, but that's the language that's used in the literature on this particular topic. So it is what it is.
The next topic I want to go into is virtual reality. But before that, are there any other things you want to touch on relating to contextual interference?
There is. I think one of the things that a lot of my particular research findings have demonstrated is that there can be value in kind of practicing along this contextual interference continuum. And so I've done a series of studies over the years, particularly with beginners or low-skilled movers, showing that there is a benefit to doing a little bit of block practice at the beginning of a practice schedule, but then moving away from that. And so for that beginner who's not skilled, giving them a little bit of repetition or a little bit of block practice early on does allow them to explore the movement, go through some trial and error, do some initial problem solving, but you don't want to keep them there. You want to then move them into, once they start having some success, now move them down the continuum of contextual interference to an intermediate amount of contextual interference, have them practice there for a while until they achieve a certain threshold of success, and then move them into a random schedule, which has high contextual interference. Through that research, I developed this new theoretical model that we just usually coin the parallel development hypothesis. And the general crux of that hypothesis is that as somebody is practicing a motor skill, there are effectively two things that are changing. One is their problem-solving capability, so becoming more intelligent as a mover, and then they're also developing the skill. So their physical capabilities are also evolving. And so what those studies have demonstrated is that if you can get the cognitive development and the motor development to happen in parallel, in unison, you've really hit a sweet spot. And so I think one way in which you hit that sweet spot is by developing a practice environment that for beginners introduces a little bit of early repetition, but then move them down the continuum. So as they are becoming more skilled, their practice environment is also becoming more challenging to match their evolving skill set. And that's consistent with a whole bunch of literature out there. I can't take credit for this larger body of work, but if you look at things like challenge point hypothesis, desirable difficulties, even looking at things like frameworks of deliberate practice, they all propose that same idea, that for beginners, the learning environment should be a little less challenging. For more advanced learners, it should become more challenging. And so as a practitioner, I think where you want to try to find a happy medium is developing a practice environment that's matching the cognitive and the physical skill sets of those learners. And so a great way to do that is through contextual interference.
And I think an interesting point to that is that I like to ask golfers or athletes in general is I want you to think over the last 3 years, what's changed in how you practice? And it's amazing how a lot of times nothing has changed over the
Yeah.
last 3 years. It's pretty much the same thing. And that
Yeah.
kind of speaks to what you said there is that as your skill level increases, you want to change the amount of contextual interference. And even at the highest level, I think it just stagnates because it becomes harder and you require more effort and creativity to start creating more contextual interference at that
hmm
really high level.
It's like anything in life. To evolve and get better, you need a stressor. So it's no different than if you're exercising and you want to improve your strength, you've got to add more weight for strength training. Because if you just keep the weight constant, you're not going to get stronger. If you want to improve your cardiovascular fitness, you've got to increase the intensity of your exercise. If you want to improve memory, you've got to stress the memory system. So skill acquisition is no different. You've got to develop some of that scar tissue. So you need the stressor. And so a lot of times you induce the stressor through increased complexity. And that, again, is from complexity looking at in terms of physical stressors, but also cognitive. We need to stress the entire system to develop some of that scar tissue to be stronger and better and faster and more intelligent as a mover. So I think that's a great way of looking at it. And this is another issue too that comes up. Golf is a great example, is with like recreational golfers. I've talked to a lot of golfers over the years, and it's like, man, my game hasn't improved in a long time. And so you start probing a little bit. And it's, yeah, because you play the same course recreationally every day or a couple times a week. Of course, you're not going to get better. There's no stressor there. You're not changing your environment. You're not changing anything about what you're doing. And yeah, you're not going to evolve. And this goes back to a lot of very basic psychological constraints of looking at developing skill acquisition in terms of getting better over time, is that it's got to be more difficult. It's got to be mission driven and things like that. So I agree completely with you.
Virtual reality is an area I'm really interested in. My first question is what sparked your curiosity in VR?
Several things. Again, if I go in my time machine and go back a decade or so, I think a lot of my initial research that started to dive into virtual reality and also augmented reality, mixed reality, extended realities, all these different platforms, really started with the work I was doing with the military. The military at the time was making pretty large investments in terms of advanced simulation, and virtual reality being one of them, and trying to understand how can we use these forms of simulation to enhance motor behavior of different military populations. And then I also did some research with medical populations, particularly surgeons, that were interested in using virtual reality as a training tool. And again, about a decade ago, to get a basic virtual reality system for a research lab, it was $200,000-$300,000 just to get started. And those systems were terrible. They were not easy to use, required a pretty in-depth background in programming. But then Oculus came out. Mark Zuckerberg bought Oculus as part of his Facebook portfolio and started releasing these gaming platforms that were a couple $100 off the shelf. And they were fantastic, really built for gaming. But I thought, holy smokes, like there's a real opportunity here now to explore some interesting research questions with this new technology that's very user-friendly, doesn't cost a lot of money, is super intuitive to use. And so that all coincided with just my own interest in understanding how can we create better simulations and practice to affect skill acquisition. And I personally believe that all forms of practice are a form of simulation. So it doesn't matter if you're at the driving range hitting a bucket of balls, that's a simulation. If you go to the batting cage and hit some balls, that's a simulation. If you put on a virtual reality headset, that's a simulation. So I think all practice is some sort of simulation. And this new emerging technology, I think, provided an opportunity to investigate a lot of simulation questions that are inherent logistical challenges, and that, especially think about like military or medical populations, the jobs that they are doing are very risky. So it's hard to practice them in the real world. They're also really expensive. So some of these military personnel, pilots, are operating multi-million-dollar aircraft. I've worked with special operators that are doing jobs that literally involve life and death decisions. So it's hard to practice that because it's dangerous, it's expensive, it's dirty. It can involve hazardous chemicals sometimes. And so it's hard to simulate that in a practice environment, but we can put it in a VR headset and simulate it. My interest started with a lot of these basic scientific questions of understanding how can we use this form of simulation to try to effectively improve motor learning and motor performance for these really high-risk occupations. And so to go back to your question, that's where it started for me. And then it's a pretty short leap to get into sports science. How can we take these same technologies and apply it? I should also add that I am inherently skeptical of technology as a practice tool. So at the same time, I was inherently interested in this new technology. I was also incredibly skeptical that it actually worked and it was effective. And I never have viewed it as a replacement for physical practice, but really a supplement to physical practice. And several years later, we now have a pretty robust portfolio in the research lab studying VR, and our findings are actually very encouraging. It does seem like if this VR technology is used appropriately, it can really be a great tool to have in the toolbox, a very nice supplement to physical practice. So that's how I got interested in it. And I'm encouraged because, again, our findings are indicating that this can be a very effective way to learn and practice motor skills.
And I want to now dive a bit deeper into that and talk about some of the research that you've conducted. Firstly, one paper titled Virtual Motivation, the Psychological and Transfer of Learning Effects of Immersive Virtual Reality Practice. I think the title is relatively self-explanatory, but can you talk about what you were trying to figure out there and what were the key findings?
Yeah, so this study is actually one that we just put out. I don't think it's been accepted yet, but I think it should be accepted and actually published in the very near future. But this actually involved a golf skill, a putting task. I should also give credit to my student, Logan Markwell. This is a series of studies that he's led as part of his dissertation work here at the University of Tennessee. What this study and all these other ones that we've done in sequence have looked at is this idea that let's have people come into the lab and they get put into one of 2 or 3 groups. So one group will come into the lab and physically practice putting golf balls on a putting green. So we've made this little makeshift putt golf course in the lab. And another group will come in and put on a virtual reality headset that's totally immersive. And then in the VR headset, we've created an exact model of the golf course that we built in the lab. So those participants that come in, put on the VR headset, practice the same golf skills, but in virtual reality. So those VR participants, when they look down at their feet, they see a golf club pointing down, extending from their hand. They also see a virtual golf ball. It's interesting because those participants actually never swing a golf club, but they swing a virtual club. They can see it, but they're not actually holding a club in their hand, their physical hand. And they're not actually hitting a real ball. They're hitting a virtual ball. So they can see the ball, and when their virtual club moves, it hits the ball, goes to a target, so we can measure accuracy and things like that. And what we have found very consistently is that if you have these 2 groups come in, one group practices putting the golf balls in virtual reality where they're not actually hitting physical golf balls. Another group comes in, actually hits physical golf balls, and they do this over a series of trials. We've done studies now, we're going multiple days of practice. And then at the end of it all, you actually give the VR group a golf club and say, okay, now actually go hit golf balls. We find that they are just as accurate compared to the group that actually practiced hitting golf balls. There's no significant differences. The other thing we've been observing too is that the VR group tends to be more motivated. They're more engaged in practice, which are really important things to consider to keep people practicing. People need to be engaged and motivated to continue to practice. And so again, these are initial results, but it's a finding that we keep discovering is that by practicing these skills in virtual reality, people seem to be learning how to putt a golf ball more accurately. And then we've also been measuring some swing kinematics, kind of like I talked about a little bit earlier with the CI studies, and finding that people in virtual reality practice are actually changing their swing mechanics when you give them a golf club. Even though they don't actually swing a golf club in practice, it's just a virtual club. So they're getting more accurate, in their actual motor behaviors changing through the course of this virtual reality practice, which is very encouraging. So again, I think it could solve some problems. If you don't have access to a golf putting surface, or you don't have access to some equipment, or it's raining outside, it seems like practicing some of these things in virtual reality can be a nice alternative, but people should still go out and hit golf balls for practice. So in short, that's what we keep finding, is that this virtual reality practice is changing motor behavior, but also changing some of these psychological factors, things like motivation, engagement, which again is all very encouraging.
And do you have any initial thoughts on why is the VR more motivating?
I think part of it is the novelty of it, just the technology. It's the gamification of it, to where it's, as a researcher, it's interesting because I've been involved at this point with lots of studies. And when you have these VR participants come in, like, they don't want to stop. They want to keep practicing in the lab. That is not normal. Usually participants, when it's time for them to go, they're ready to get out of there. And so I thought, oh, this is interesting. So part of it could be the novelty of it, or just the gamification of it. It could just be it's more pleasurable just to experience this new medium of information. I don't think we know yet. We know this effect is there, but getting to the mechanism is something that is going to require more investigation. Logan, who I mentioned a little bit earlier, he just wrapped up a study where he's having people come in over multiple days of practice. And Logan's results that he's now processing are showing, like, yeah, even after days of practice, the effect seems to still be there. And who knows, after weeks of doing this, how it might affect it. And again, I've seen similar findings with military populations. We're doing stuff with medical populations. We're seeing the exact same effects. And so it's encouraging. It doesn't seem like it's unique to golf putting. This seems to be going to be a bit broader across the human experience.
And there's a second paper. Are there any other additional thoughts on that? One titled Off the Shelf, Investigating Transfer of Learning Using Commercially Available Virtual Reality Equipment. Any findings that are relevant?
I think those findings are the same. And as the title of that paper implies, it's using something that's literally just off the shelf, something that doesn't require a lot of modification. And so this is really important for us as researchers to consider. We don't want to create this technology that requires somebody to do a lot of programming, because you start to lose the engagement. And so this was a particular study where we just literally got a VR headset out of the box or off the shelf and just used games or applications that were just readily available. And then thought, okay, how can this stuff that requires no modification, does that also have the same effect? And the short answer is it does. And so we're doing studies now in the lab where we're getting into issues of what's called fidelity. How real does this need to be? And maybe I can come back on in the future and talk about what we see. But conventional wisdom would have us believe that you've got to have all this really rich detail for the VR experience to be effective. Our initial results are suggesting that is not accurate. You might be able to get pretty good learning effects with really poor quality optics, which again is encouraging. It doesn't have to be something that's really spectacular. And then again, I'm seeing that with the work I've done with the military and medical populations, that you seem to be able to get a pretty good return on the investment when it comes to motor learning.
Thank you for listening to today's episode of Coach Noah Talks. If you enjoyed this episode, please subscribe to the Golf Performance newsletter. This is where I share written, audio, and video content designed to help golfers take their game to the next level. All the relevant links from today's episode and to the newsletter can be found in the description.